Jakarta Servlet Architecture. Here you can see an architectural diagram of Jakarta Servlet. A Jakarta Servlet, formerly Java Servlet, is a Java software component that extends the capabilities of a server. Although servlets can respond to many types of requests, they most commonly implement web containers for hosting web application on web servers, and thus qualify as a server-side servlet web API. Such web servlets are the Java counterpart to other dynamic web content technologies such as PHP and ASP.NET. Now we are focusing on client. A client, for example, a web browser, accesses a web server and makes an HTTP request. Here you can see multi-tiered applications. The Jakarta EE platform uses a distributed multi-tiered application model for enterprise applications. Application logic is divided into components according to function, and the application components that made up a Jakarta EE application are installed on various machines depending on the tier in the multi-tiered Jakarta EE environment to which the application components belongs. This figure shows two multi-tiered Jakarta EE application divided into tiers described in the following list. The Jakarta EE application parts shown in this figure are presented in here. Client tier components run on the client machine. Web tier components run on the Jakarta EE server. Business tier components run on Jakarta EE server. Enterprise Information System EIS tier software runs on the IES server. Although a Jakarta EE application can consist all tiers shown in this figure, Jakarta EE multi-tiered application are generally considered to be three-tiered application because they are distributed over three locations: client machines, the Jakarta EE server machine, and the database or legacy machines at the backend. Three-tiered applications that run in this way extend the standard two-tiered client-server model by placing a multi-threaded application server between client application and the backend storage. Security. Although the other enterprise application models require platform-specific security measures in each application, the Jakarta EE security environments enable security constraints to be defined at the deployment time. The Jakarta EE platform makes applications portable to a wide variety of security implementations by shielding application developers from the complexity of implementing security features. Jakarta EE platform provides standard declarative access control rules that are defined by the developer and interpreted when the application is deployed on the server. Jakarta EE also provides a standard login mechanisms so that the application developers do not have to implement this mechanism in their applications. The same application works in a variety of security environments without changing the security code. Jakarta EE applications are made up of components. A Jakarta EE component is self-contained functional software unit that is assembled into Jakarta EE application with its related classes and files, and that communicates with other components. Jakarta EE specification defines the following Jakarta EE components: application clients and applets are components that run on the client. Jakarta servlet, Jakarta faces, and Jakarta server pages technology components are web components that run on the server. Enterprise bean components. Enterprise beans are business components that run on the server. Jakarta EE components are written in Java programming language and are compiled in the same way as any program in the language. The difference between Jakarta EE component and standard Java classes are that Jakarta EE components are assembled into a Jakarta EE application. They are verified to be well formed and in compliance with the Jakarta EE specification, and they are deployed to production where they can run and managed by the Jakarta EE server. Jakarta EE clients. A Jakarta EE client is usually either a web client or an application client. A web client consists two parts: a dynamic web pages containing various type of markup language, HTML, XML, and so on, which are generated by web components running in the web sphere. Web browser, which renders the pages received from the server. A web client sometimes called a thin client. Thin clients usually do not query databases, execute complex business rules, or connect to legacy applications. When you use a thin client, such heavyweight operations are offloaded to enterprise beans executing on Jakarta EE server, where they can leverage the security, speed, services, and reliability of Jakarta EE server-side technologies. Application clients run on a client machine and provides a way for users to handle tasks that require a richer user interface than can be provided by a markup language. An application client typically has a graphical user interface (GUI) created from the Swing API or an abstract Windows toolkit (AWT) API, but a command line interface is certainly possible. Application client directly access enterprise beans running in the business tier. However, if application requires if application requirements warrant it, an application client can open an HTTP connection to establish a communication with the servlet running in the web tier, web tier. Application clients written in languages other than Java can interact with Jakarta EE servers, enabling the Jakarta EE platform to interoperate with legacy systems, clients, and non-Java languages. Applets, a web page received from a web tier, can include embedded applet written in Java programming language. An applet is a small client application that executes in the Java virtual machine installed in the web browser. However, a client systems will likely need the Java plugin and possibly a security policy file for the applet to successfully execute in the web browser. Web component are the preferred API for creating a web client program because no plugins or security policy files are needed on the client system. Also, web components enable cleaner and more modular application design because they provide a way to separate applications programming from the web page design. Personnel involved in web page design thus do not need to understand Java programming language syntax to do their jobs. Here you can see multi-tiered applications. Here you can see Jakarta EE application 1 application client and Jakarta EE application 2 web pages are in client tier. Client tier is connected to client machine, and client tier is connected to web tier. Jakarta server pages faces are in web tier, and web tier is connected to business tier. Enterprise beans are in business tier, and web tier and business tier is connected to Jakarta EE server here, and business tier is connected to EIS tier. Databases are in EIS tier. Database server is connected to this tier. Here you can see Jakarta EE APIs in the client container. This figure shows the availability of Jakarta EE APIs in the application client container. Here you can see new in Jakarta EE here. Here you can see application client is inside the application client's container, and here you can see Jakarta persistence management, WS metadata, web services, JSON P, JMS, JAX, WS, bean validation, Jakarta mail, CDI, dependency injection, and it's connected to here Java SC. Here you can see Jakarta web application request handling. A web application is a dynamic extension of a web or application server. Web applications are of following types. Presentation oriented. A presentation oriented web application generates interactive web pages containing various type of markup language, HTML, XHTML, XML, and so on, and dynamic content in response to requests. Development of service, and the other type is service oriented. A service-oriented web application implements the endpoint of a web service. Presentation-orient applications are often clients of service-oriented web applications. In Jakarta E platform, web components provide a dynamic extension capabilities for a web server. Web components can be Jakarta servlets, web pages implemented with Jakarta Faces technology, web server endpoints, or Jakarta server pages. This figure illustrates the interaction between a web client and a web application that uses a servlet. The client sends an HTTP request to the server. A web server that implements Jakarta Servlet and Jakarta Server Pages technology converts the request into an HTTP servlet request object. This object is delivered to a web component which can interact with Java Beans component or a database to generate dynamic content. The web component can then generate a HTTP servlet response or can pass the request to another web component. A web component eventually generates a HTTP servlet response object. The web server converts this object to an HTTP response and return it to the client. Servlets are Java programming language classes that dynamically process requests and construct responses. Java technologies such as Jakarta Faces and Facelets are used for building interactive web applications. Frameworks can also be used for this purpose. Although servlets and Jakarta Faces and Facelets pages can be used to accomplish similar things, each has its own strength. Servlets are best suited for service-oriented application. Web service endpoints can be implemented as servlets, and the control functions of a presentation-oriented application such as dispatching requests and handling non-textual data. Jakarta Faces and Facelets pages are more appropriate for generating text-based markup such as XHTML, and are generally used for presentation-oriented applications. The web components are supported by the services of a runtime platform called Web Container. A web container provides such services as request dispatching, security, concurrency, and lifecycle management. A web container can give a web component access to such APIs as naming, transactions, and email. Certain aspects of web application behavior can be configured when the application is installed or deployed to a web container. The configuration information can be specified using Jakarta E annotations or can be maintained in a text file in XML format called Web Application Deployment Descriptor (DD). A web application DD must confirm the schema described in the Jakarta Servlet specification. Here you can see a web client. Step 1 here, HTTP request is passed from web client to HTTP servlet request. Step 2 here, HTTP servlet request is connected to web components. Step 3, web components interacts with Java Bean components, and step 4, web components interacts with database, and Java Beans components interacts with database, and web components is connected to HTTP servlet response, step 5, and step 6, HTTP response is passed from HTTP servlet response to web client. And here web client is connected to HTTP servlet request, and HTTP servlet response is connected to web client. As an example, we can consider this. In this servlet class, we injected greeting service to handle the message here, and you can see here here you can see the method string get parameter string name returns the value of a request parameter as string, or null if the parameter does not exist. Request parameters are extra information sent with the request. For HTTP servlets, parameters are contained in the query string or posted from form data. This method is in the interface servlet request, and it's in package jakarta.servlet and module jakarta.servlet. Here write message to HTTP response. As an example 2, we can consider this code segment. Here the method print writer get writer, this returns a print writer object that can send character sets that can send character text to client. The print writer uses the character encoding returned by get character encoding. If the response character encoding has not specified as described in get character encoding, that is, the method just return the default value ISO-8859-1, get writer updates it to ISO-8859-1, and this is in the interface servlet response, and it is in package jakarta.servlet, and it's in package module jakarta.servlet. Here we use push builder object to send an image to the client before it is requested by img source tag. In other words, the browser doesn't need to do another request what it usually does with IMG SRC to have an image available for rendering. It might seem as if it doesn't make too much difference for a single image, but it would with dozens, 100 or 1,000 images. There's less traffic for your client and from your server. That's better performance at all. In the error handler servlet, we can access the error details using error attributes provided in the request. In top here you can see we can set up our custom error handling policy for the java.lang.exception in web.xml. Now we are focusing on web listener. When the web listener is the Oracle HTTP server powered by Apache, the connection to the OC4J servlet container goes through the mod_OC4J module. The servlet container is a part of a web server or application server that provides the network services over which request and response are sent, decodes MIME-based request and formats MIME-based responses. A servlet container also contains and manages servlets through their life cycle. Once the servlet has finished processing the request, the servlet container ensures that the response is properly flushed and returns control back to the host web server. Here you can see web tier and Jakarta EE applications. Here web components. Jakarta EE web components are either servlets or web pages created using Jakarta Faces technology or Jakarta Server Pages technology. Servlets are Java programming classes that dynamically process requests and construct responses. Jakarta Server Pages are text-based documents that execute as servlets but allow more natural approach to creating static content. Jakarta Faces technology built on servlets and Jakarta Server Pages technology and provides a user interface component framework for web applications. Static HTML pages and applets are bundled with web components during application assembly. but are not considered web component by Jakarta EE specification. Server-side utility classes can also be bundled with web components, and like HTML pages are not considered web components. As shown in this figure, the web tier, like the client tier, might include Java Beans components to manage the user input and send that input to enterprise beans running in the business tier for processing. As an example, we can consider this code here. Here the method default push builder, new push builder, instantiates a new instance of a push builder for issuing a server push responses from the current request. This method returns null if the current connection does not support server push, or server push has been disabled by the client via a settings enable push settings frame value of 0. This is in the interface HTTP servlet request, and that is in the package jakarta.servlet.http, and that is in the module jakarta.servlet. Here the interface push builder, a builder request to be pushed according to section 8.2 of RFC 7540. A promised request must be cacheable and safe without a request body. And here the path and string path here sets the URI path to be used for the push, and it returns push builder. Here add header, string name and string value. Add the request header to be used for the push. Here the method push void push push a resource given the current state of the builder. The method must be non-blocking. Here you can see a annotation type web listener. This annotation is used to declare a web listener. Any class annotated with web listener must declare a web listener. Must implement one or more of the servlet context listener, servlet context attribute listener, servlet request listener, servlet request attribute listener, HTTP session listener or HTTP session attribute listener or HTTP session ID listener interfaces. Here the interface servlet context listener interface for receiving notification events about servlet context lifecycle changes. The method default void context initialized servlet context SCE receives notification that the web application initialization process is starting. At web listener, the web listener annotation is used to annotate a listener to get events for various operations on a particular web application context. The classes annotated with at web listener must implement one of the following interfaces: Jakarta.servlet context listener, Jakarta.servlet context attribute listener, Jakarta.servlet request listener, Jakarta.servlet request attribute listener, Jakarta.servlet.http session listener, Jakarta.servlet.http session attribute listener, Jakarta.servlet.http session ID listener. As an example 3, we can consider this. Oracle 99AS containers. Port 7777 is the default port for OHS web listener. If you change the default port number of the OHS, then specify the new port number after the host name as follows here. As an exception example, we can consider this one occurred in the environment with Spring Boot, IntelliJ and Maven. Exception encountered during context initialization, cancelling refresh attempt, org.spring framework.context.application context exception, unable to start web server. Nested exception is java.lang.no class def found error. Jakarta/servlet/JSP/JSP factory. Now we are focusing on Servlet Container. The Servlet Container is a part of a web server or application server that provides the network services over which requests and responses are sent, decodes MIME-based requests, and formats MIME-based responses. A servlet container also contains and manages servlets through their life cycle. Here you can see Jakarta EE architecture diagram. In this color you can see optional in Jakarta EE9. The required relationships of architectural elements of Jakarta EE platform are shown in this Jakarta EE architecture diagram. Note that this figure shows the logical relationships of elements. It is not meant to imply a physical partitioning of elements into separate machines, processes, address spaces, and virtual machines. The containers denoted by separate rectangles are Jakarta EE runtime environments that provide required services to the application components represented in the upper half of the rectangle. The services provided are denoted by the boxes in the lower half of the rectangle. For example, application client container provides Jakarta messaging APIs to application clients as well as other services represented. All these services are here, and the arrows represent required access to other parts of Jakarta EE platform. The application client container provides application clients with direct access to Jakarta EE required database through Java API for connected with database systems. JDBC API. Similar access to databases is provided through Java server pages, server faces applications, server faces applications, and servlets by the web container. And to enterprise beans by the enterprise beans container. As indicated, the APIs of Java platform, the standard edition Java SE are supported by Java SE runtime environment for each type of application components. The application clients are Java programming language programs that are typically GUI programs that execute on desktop computer. Application clients offer a user experience similar to that of native applications and have access to all of the facilities of Jakarta EE middle tier. Servlets, server pages, server faces, applications, filters, and web event listeners typically execute in a web container and may respond to HTTP requests from web clients. Servlets, server pages, server faces, applications, and filters may be used to generate HTML pages that are an application user interface. They may also be used to generate XML or other format data that is consumed by other application components. A special kind of servlets may provide support for web services using SOAP HTTP protocol. Server pages created with Jakarta Server Pages technology or Jakarta Server Faces technology, web filters, and web event listeners are referred to collectively in this specification as web components. Web applications are composed of web components and other data such as HTML pages. Web components execute in a web container. A web server includes a web container and other protocol support, security support, and so on as required by Jakarta EE specifications. Jakarta Enterprise Beans components execute in a managed environment that supports transactions. Enterprise Beans typically contain a business logic for Jakarta EE application. Enterprise Beans may directly provide web services using the SOAP HTTP protocol. Jakarta EE database. Jakarta EE platform requires a database accessible through the JDBC API for storage of business data. The database is accessible from web components, enterprise beans, and application client components. Database need not to be accessible from applets. The Jakarta E product provider must provide a pre-configured default data source for use by the application in accessing this database. Here you can see application client container. Application client is inside application client container, and we can see the services here: messaging, activation, mail, JSON P, JSON B, annotations, persistence, bean validation, messaging beans, interceptors, CDI and DI, and you can see the optional in Jakarta E, XML binding, enterprise WS, XML web service, WS metadata, SOAP with attachment, and you can see Java SE below. Application client container is connected to web container. HTTP and SSL is passed from application client container to web container. Server pages and servlets are inside web container. You can see the services here: enterprise beans, expression language, messaging, transactions, activations, mail, connectors, result, RESTful WS, WebSocket, JSON P, JSON B, concurrency, batch, authentication, authorization, authentication, security, standard tag library, server faces, annotations, persistence, bean validation, manage beans, interceptors, CDI and DI, and you can see the optional services here. Optional services inside web container: XML binding, enterprise WS, XML web services, WS metadata, SOAP with attachment, and below that you can see Java SE, and web container is connected to enterprise beans container. Enterprise beans are inside enterprise beans container. You can see the services there: messaging, transaction, activation, mail, connectors, JSON P, JSON B, concurrency, batch, authorization, authentication, security, annotations, persistence, bean validation, manage beans, interceptors, CDI and DI, and you can see optional in Jakarta EE here: XML binding, enterprise WS, XML web service, WS metadata, SOAP with attachment, and application client container is connected to enterprise beans container too. Application client container, web container, and enterprise bean container are connected to database here. Here you can see Jakarta EE interoperability. Many of APIs provide interoperability with components that are not part of the Jakarta EE platform, such as external web or COBA services. Jakarta EE interoperability illustrate the interoperability facilities that may be available in the Jakarta EE platform. Directions of the arrows indicate the server-client relationships of the components. Here you can see Jakarta EE platform: application client container, web container, EJB container, and database are inside Jakarta EE platform. JRMP SOAP, HTTP, HTTP SSL, and IIOP are passed from application client container. And application client container is connected to a web container, an EJB container, and database. JRMP, IIOP are passed from web container, and web container HTTP, SSL, and SOAP, HTTP are passed back and forth from and to from web container. Web container is connected to EJB container and database. JRMP and IOP and HTTP SSL are passed from EJB container. SOAP, HTTP are passed back and forth from EJB container, and EJB, IIOP, SSL are passed to EJB container. EJB container is connected to database. Here you can see Jakarta EE server and containers. Normally, Jakarta EE containers think client multi-tiered applications are hard to write because they involve many lines of intricate code to handle transaction and state management, multi-threading, resource pooling, and other complex low-level details. The component-based and platform-independent Jakarta EE architecture makes application easy to write because business logic is organized into reusable components. In addition, the Jakarta EE server provides underlying services in the form of a container for every component of type. Because you do not have to develop these services yourself, you are free to concentrate on solving the business problem at hand. Containers are the interface between a component and the low-level platform-specific functionality that supports the component. Before it can be executed, a web enterprise bean or application client component must be assembled into Jakarta EE module and deployed into its container. Assembly of processes involving specifying container settings for each component in Jakarta EE application and for Jakarta EE application itself. Container settings customize the underlying support provided by Jakarta EE server, including such services as security, transaction management, Java naming and directory service, JNDI, API lookups, remote connectivity. Here are some highlights. Jakarta EE security model lets you to configure a web component or enterprise bean so that the system resources are accessed only by authorized users. Jakarta EE transaction model lets you specify relationships among methods that made up a single transaction, so that all methods in one transaction are treated as a single unit. JNDI lookup service provides a unified interface for multiple naming and directory services in the enterprise so that application components can access these services. Jakarta EE remote connectivity model manages low-level communication between clients and enterprise beans. After an enterprise bean is created, client invoke methods on its as if it were in the same virtual machine. Because Jakarta EE architecture provides configurable services, components within the same application can behave differently based on where they are deployed. For example, enterprise bean can have security settings that allow it a certain level of access to a database in certain level of access to database data in one production environment and another level of database access in another production environment. The container also manages non-configurable services such as enterprise bean, servlet lifecycles, database connection resource pooling, and access to Jakarta EE platform APIs. The deployment process install Jakarta EE application components in Jakarta EE containers as illustrated in here. The server and containers are as follows. Jakarta EE server, the runtime portion of Jakarta EE product. Jakarta EE server provides enterprise and web containers. Jakarta enterprise bean container manages the execution of enterprise beans for Jakarta EE applications. Jakarta enterprise beans and their container runs on Jakarta EE server. Web container manages the execution of web pages, servlets, and some enterprise bean components for Jakarta EE applications. Web components and their container run on the Jakarta EE server. Application client container manages the execution of application client components. Application clients and their container run on the client. Applet container manages the execution of applets, consist of web browser and Java plugin running on the client together. Here you can see application client, and application client is inside application client container. Application client container and web browser are inside client machine here. Application client container is connected to EJB container here. Here you can see web container is connected to EJB container. Web container and EJB container are inside the Jakarta EE server. Servlets and web page are inside web container. Enterprise beans are inside EJB container. Here application client container interacts with the EJB container, and EJB container interacts with web container. EJB container interacts with the database. Here you can see EE containers, Jakarta EE containers. So this figure shows the relationships among the Jakarta EE containers. Here you can see browser, and you can see here client system, browser, and application client container are inside browser client system, and application client is inside application client container. So and the browser interacts with web container. Jakarta EE server contains web container and EJB container. Jakarta server faces and servlet are inside web container. Web container interacts with EJB container. EJBs are inside EJB container. EJB container interacts with database, and EJB container interacts with application client container. application client is inside application client container. Here you can see Jakarta EE APIs in the web container. Here you can in this color you can see new in Jakarta EE. So this figure shows the availability of Jakarta EE APIs in the web container. So here you can see servlets and Jakarta server faces are inside web container. Then you can see the APIs, the new APIs are here. The WebSocket concurrency utilities, batch and JSON-P are new APIs in new in Jakarta E. You can see bean validation, EJB Lite, EL, Jakarta Mail, JSP connectors, Jakarta persistence, JMS management, WS metadata, web services, JACC, JASPIC, JAX-RS, JAX-WS, JSTL, JTA, CDI, dependency injection, and you can see next to it it's connected to Java SE. As an example, we can consider class servlet container, a servlet or filter for deploying root resources classes. This is in package org.glassfish.jersey.servlet. Here you can see the basic deployment descriptor example. The deployment descriptor conveys the element and configuration information of a web application between application developers, application assemblers, and deployers. For Servlet 6.0, the deployment descriptor is defined in terms of an XML schema document. For backward compatibility of application written to previous versions of the API, any deployment descriptors written to comply with earlier versions specifications must still be supported such that applications runtime the applications continue to deploy. For actual XST files, please visit https://jakarta.ee/ns/jakarta.ee/. Deployment descriptor elements. The following type of configuration and deployment information are required to be supported in the web application deployment descriptor for all servlet containers. Servlet context init parameters, session configuration, servlet mappings, servlet declarations, servlet mappings, application lifecycle listener classes, filter definition and filter mappings, MIME type mappings, welcome file list, error pages, local and encoding mappings, security configuration including logging -config, security-constant, deny-uncovered- HTTP-methods, security-roles, security-role-ref, and run-s. Rules for processing the deployment descriptor. This section, here we'll consider some general rules that web containers and developers must note concerning the processing of deployment descriptor for web application. Web containers must remove all leading and trailing white space, which is defined as S white space in XML 1.0. http://www.www.tr/tr/2000/wd-xml-2E-20000814 for element content of text nodes and of a deployment descriptor. The deployment descriptor must be a valid against schema. Web containers and tools that manipulate web applications have a wide range of options for checking the validity of a var. This includes checking the validity of the deployment descriptor document held within. Additionally, it is recommended that web containers and tools that manipulate web applications provide a level of semantic checking. For example, it should be checked that a role reference in a security constant has the same name as one of the security roles defined in the deployment descriptor. In cases of non-conformant web applications, tools and containers should inform the developer with descriptive error messages. High-end application server vendors are encouraged to supply this kind of validity checking in the form of tools separate from the container. Sub-elements under web-app can be in an arbitrary order in this version of specification because of the restriction of this is we are referring version 6.0 here. Because the restriction of XML schema, the multiplicity of elements distributable, session config, welcome file list, JSP config, logging config, and local encoding mapping list was changed from optional to 0 or more. The containers must inform the developer with a descriptive error message when the development descriptor contains more than one element of session config, JSP config, and logging config. Container must concentrate the items welcome file list and local encoding mapping list when there are multiple occurrences. Multiple occurrences of distributable must be treated exactly in the same way as the single occurrence of distributable. URI paths specified in the deployment descriptor are assumed to be in URL decoded form. The containers must inform the developer with the descriptive error message when URL contains CR within bracket #xd or LF within bracket #xa. The containers must perceive all other character including white space and in URL. Containers must attempt to canonize paths in the deployment descriptor. For example, paths of form /a// /b must be interpreted as /b. Paths beginning or resolving to path that begins with .. are not valid paths in the descriptor in the deployment descriptor. URI path referring to resource relative to the root of the var or path mapping relative to the root of the var unless otherwise specified should begin with a leading /. In elements whose value is an enumerated type, the value is case sensitive. The deployment descriptor for this version 6.0 for the specification is available at http ://jakarta.ee//web-app_0.xsd. So this example illustrates the usage of definition listed in the deployment descriptor schema. Here you can see deployment. In this example, you can see deployment descriptor example using security. This is here role name is used in code. In the WebLogic server servlet container, this example demonstrates how to disable access logging. Logging access for servlets can be expensive with regard to server performance. Therefore, in cases where access logging is not required, you can improve performance by disabling logging to the access log file. The optional access logging disabled property in the container descriptor in WebLogic can be used to specify whether access logging for an underlying web application is disabled. The property, if the property is set to true, then the application access are not logged. If the property is not defined or is set as false, the application access is logged. Note the access logging disabled property functions at the web application level. Therefore, it is defined in the web application. It does not affect other web applications. This property works under both development mode and production mode. Note to disable logging for internal application, use this property weblogic.servlet.logging.log internal app access equal false. As an exception example, we can consider class unavailable exception. Defines an exception that a servlet or filter throws to indicate that it is permanently or temporarily unavailable. Servlet containers can safely treat both type of unavailable exceptions in the same way. However, treating temporary unavailability effectively makes the servlet container more robust. Specifically, the servlet container might block requests to the servlet or filter for a period of time suggested by the exception, rather than rejecting them until the servlet container restarts. This is in package jakarta.servlet. As an error example, we can consider this one. the error page here. Error pages to allow developers to customize the appearance of content returned to a web client when a servlet generates an error. The deployment descriptor defines a list of error page descriptions. Syntax allows the configuration of resources to be returned by the container either when a servlet or filter calls send error on a response for a specific status code, or if the servlet generates an exception or error that propagates to the container. This is in web.xml. If the send error method is called on the response, container consults the list of error page declaration for the web application that use the error code syntax and attempt to match. If there's no match, the container returns the resource as indicated by the location entry. A servlet or servlet filter may throw following exception during processing of a request: runtime exceptions or errors, servlet exception or subclass thereof, IO exceptions or subclass thereof. Web application may have declared error pages using exception type element. In this case, the container matches the exception type by comparing the exception thrown with the list of error page definitions that use exception type element. A match results in the container returning the resource indicated in the location entry. The closest matched in the hierarchy wins. If no error page declaration containing an exception type fits using the class hierarchy match and the exception thrown is servlet exception or subclass thereof, the container extract the wrapped exception as defined by servlet exception.getRootCause method. A second pass is made over the error page declarations, again attempting the match against the error page declaration but using wrapped exception instead. Error page declarations using exception type element in the deployment descriptor must be unique up to the class name of the exception type. Similarly, error page declaration using error code element must be unique in the deployment descriptor up to the status code. If an error page element in the deployment descriptor does not contain exception type or error code, an error page is default error page. Error page mechanism described does not intervene when errors occur when the invoke using request dispatcher or filter.doFilter method. In this way, the filter or servlet using request dispatcher has the opportunity to handle error generated. If a servlet generates an error that is not handled by the error page mechanism, as described here, the container must ensure to send a response within status 500. The default servlet and container will use send error method to send 4xxx and 5xx status responses so that the error mechanism may be invoked. Default servlet and container will use the set status method for 2xx and 3xx responses and will not invoke the error page mechanism. If the application is using asynchronous operations, it is the application responsible to handle all errors in application created threads. The container may take care of the errors from the thread issued via async context.start. For handling errors that occur during async context.dispatch, go through dispatch error handling informations. Error filters the page. Error page mechanism operates on original unwrapped unfiltered request and response object created by the container. Some mechanism may be used to specify filters that are applied before an error response is generated. Now we are focusing on Servlet. A servlet is a Jakarta technology-based web component managed by a container that generates dynamic content. Like other Jakarta technology-based components, servlets are platform-independent Java classes that are compiled to platform-neutral bytecode that can be loaded dynamically into and run by a Jakarta technology-enabled web server. Containers, sometimes called servlet engines, are web server extensions that provide servlet functionality. Servlets interact with web client via a request response paradigm implemented by the servlet container. Here you can see architecture diagram of servlet lifecycle in Java. This diagram represents the lifecycle of a servlet. When a request is sent for a particular web page, the servlet corresponding to it must be initialized. The servlet container, web container, will load the servlet and create an instance of it through init. All subsequent requests to the same web page will result in invoking service method. This method will typecast the servlet request and servlet response objects to HTTP servlet request and HTTP servlet response objects respectively. Servlets can handle multiple requests concurrently, since each request result a new thread. The destroy method is only called once. All threads within the servlet service methods have exited or after a timeout period. A servlet is managed through a well-defined life cycle that defines how it is loaded and instantiated and initialized, handle requests from clients, and is taken out of service. This life cycle is expressed in the API by the init, service, and destroy methods of the Jakarta servlet Jakarta.servlet.servlet interface that all services servlets must implement directly or indirectly through generic servlet or HTTP servlet abstract classes. The servlet container is loading and instantiation. The servlet container is responsible for loading and instantiating servlets. The loading and instantiation can occur when the container is started or delayed until the container determines the servlet is needed to service a request. When a servlet engine is started, the needed servlet classes must be located by the servlet container. The servlet container loads the servlet class using normal Java class loading facilities. The loading may be from a local file system, a remote file system, or other network services. After loading the servlet class, the container instantiate it for use. Initialization. After the servlet object is instantiated, the container must initialize the servlet before it can handle requests from the client. Initialization is provided so that the servlet can read persistent configuration data, initialize costly resources such as JDBC API based connections, They perform other one-time activities. The container initializes the servlet instance by calling init method of the servlet interface with a unique per servlet declaration object implementing servlet config interface. This configuration object allows the servlet to access name value initialization parameters from the web application configuration information. The configuration object also gives the servlet access to an object implementing servlet context interface that describes the servlet's runtime environment. Error conditions on initialization. During initialization, the servlet instance can throw an unavailable exception or a servlet exception. In this case, the servlet must not be placed into active service and must be released by the servlet container. The destroy method is not called as it is considered unsuccessful initialization. A new instance may be instantiated and initialized by the container after a failed initialization. The exception to this rule is when an unavailable exception indicates a minimum time of unavailability. The container must wait for the period to pass before creating and initializing a new servlet instance. Tool considerations. The triggering of static initialization methods when a tool loads and introspects a web application is to be distinguished from the calling of the init method. Developers should not assume a servlet is in an active container runtime until the init method of the servlet interface is called. For example, servlet should not try to establish connections to database or Jakarta Enterprise Beans containers when only static class initialization methods have been invoked. Request handling. After servlet is properly initialized, the servlet container may use it to handle client requests. Requests are represented by request object type, objects of type servlet request. The servlets fill out responses to requests by calling methods of a provided object of type servlet response. These objects are passed as parameters to service method of the servlet interface. In the case of HTTP request, the object provided by the container are of type HTTP servlet requests and HTTP servlet response. Note that servlet instance placed into service by a servlet container may handle no request during its lifetime. Multi-threading issues. Servlet container may send concurrent requests to the service method of the servlet. To handle the request, application developer must make adequate provisions for concurrent processing with the multiple threads of the service method. It is strongly recommended that developers not synchronize the service method or methods dispatched to it because of the detrimental effects on the performance. Exceptions during request handling. A servlet may throw either a servlet exception or an unavailable exception during service request, during the service of a request. A servlet exception signals that some error occurred during the processing of the request and that container should take appropriate measurement to clean up the request. An unavailable exception signals that the servlet is unable to handle request either temporarily or permanently. If a permanent unavailability is indicated by unavailable exception, the servlet container must remove the servlet from service. Call its destroy method and release the servlet instance. Any request refused by the container by that cause must be returned with SC not found for response. If temporary unavailability is indicated by the unavailable exception, the container may choose to not route any request through the servlet during the time period of the temporary unavailability. Any request refused by the container during this period must be returned with the SC service unavailable 503 response status along with the retry after header indicating when the unavailability will terminate. The container may choose to ignore the distinction between permanent and temporary unavailability and treat all unavailable exceptions as permanent, thereby removing a servlet that throws any unavailable exception from service. Asynchronous processing. Sometimes a filter or servlet is unable to complete the processing of a request without waiting for a resource or event before generating response. For example, a servlet may need to wait for an available JDBC connection, for a response from the remote web service, for a JMS message, or for an application event before processing to generate a response. Waiting within the servlet is an inefficient operation as it is a blocking operation that consumes a thread and other limited resources. Frequency of slow resource such as a database may have many threads blocking waiting for access and can cause thread starvation and poor quality of service for an entire web container. The asynchronous processing of request is introduced to allow the thread to return to the container and perform other tasks. When asynchronous processing begins on the request, another thread or callback may either generate the response and call complete or dispatch the request so that it may run in the context of the container using the async context.dispatch method. Typical sequence of events for asynchronous processing is the request is received and passed via normal filters for authentication, etc. to the servlet. Step 2, the servlet processes the request parameters or content to determine the nature of the request. Step 3, event 3, the servlet issues request for resources or data. For example, send a remote web server request or joins as queue waiting for a JDBC connection. 4, the servlet returns without generating a response. 5, after some time the request resource becomes available, the thread handling that event continues processing either in same thread or by dispatching to a resource in the container using async context. Other thread safety, other than the start async and complete method, implementation of the request and response objects are not guaranteed to be thread safe. This means that they should either only be used within a scope of the request handling thread, or the application must ensure that the access to the request and response objects are thread safe. If the thread created by the application uses the container manage objects such as the request and response object, those objects must access only within the object's lifecycle. Be aware that other than start async and complete methods, the request and response object are not thread safe. Of those who access multiple threads, that the access should be synchronized or be done through a wrapper to add the thread safety. For instance, synchronizing the call of methods or call of the methods to access the request attribute, or using a local output stream for response object within the thread. The upgrade processing in HTTP 1.1, the upgrade header allows the client to specify additional communication protocols that it supports and would like to use. If the server finds an appropriate switch protocols, then new protocols will be used in subsequent communication. The Servlet container provides a HTTP upgrade mechanism. However, the Servlet container itself does not have knowledge about the upgraded protocol. The protocol processing is encapsulated in the HTTP upgrade handler. Data reading and writing between Servlet container and the HTTP upgrade handler is in the byte stream. When an upgrade request is received, the servlet can invoke HTTP servlet request.upgrade method, which start the upgrade process. This method instantiates the given HTTP upgrade handler class and handler class. The return update HTTP handler instances may be further customized. Application prepares and sends appropriate response to the client. After exiting the service method of the servlet container completes the processing of all filters and marks the connection to be handled by the HTTP upgrade handler. It then calls the HTTP upgrade handler's init method, passing web connection to allow the protocol handler access to the data streams. The servlet filters only process the initial HTTP request and response. They are not involved in subsequent communications. In other words, they are not invoked once the request has been upgraded. HTTP upgrade handler may use non-blocking I/O to consume and produce messages. The application developer has the responsibility for thread-safe access of the servlet input stream and servlet output stream while processing the HTTP upgrade. When the upgrade processing is done, HTTP upgrade handler.destroy will be invoked. End of service. The servlet container is not required to keep the servlet loaded for any particular period of time. The servlet instance may be kept active in the servlet container for a period of milliseconds for the lifetime of the servlet container, which could be a number of days, months, or years, or any amount of time in between. When a servlet container determines that the servlet should be removed from the service, it calls destroy method of the servlet interface that allow the servlet to release any resources it is using and save any persistent state. For example, the container may do this when it wants to conserve memory resources or when it is being shut down. Before servlet container calls destroy method, it must allow any threads that are currently running the service method of the servlet to complete the execution or exceed the server defined timeout, server defined time limit. Once destroy method is called on the servlet instance, the container may not route other requests to that instance of the servlet. If the container needs to enable the servlet again, it must do so with a new instance of the servlet class. After the destroy method completes, the servlet container must release the servlet instance, so it is eligible for garbage collection. Here the init servlet config method called by the servlet container to indicate to a servlet that servlet is being placed into service. Here the void service servlet request servlet response method called by the servlet container to allow servlet to respond to a request. Here void destroy called by the servlet container to indicate to a servlet that the service is being taken out of service. In interface HTTP servlet, we can see some additional methods. Protected void do delete, HTTP servlet request HTTP servlet request response called by the server via the service method to allow the servlet to handle the delete request. Protected void do get HTTP servlet request HTTP servlet response called by the server via the service method to allow the servlet to handle get request. Protected by do head. HTTP servlets request HTTP servlet response called by the server via do head one is received an HTTP head request from the protected service method and handles the request. Protected void do options. HTTP servlet request HTTP servlet response called by the server via the service method to allow a servlet to handle the options request. Protected void do post. HTTP servlet request HTTP servlet response called by the server via service method to allow a servlet to handle the post request. Protected void do put. HTTP servlet request HTTP servlet response called by the server via service via the service method to allow the servlet to handle a put request. Protected void do trace. HTTP servlet request HTTP servlet response called by the server via the service method to allow a servlet to handle a trace request. Protected void get last modified. HTTP servlet request return the time of the HTTP servlet request object was last modified in milliseconds since midnight January 1st 1970 GMT. Protected void service HTTP servlet request HTTP servlet response received standard HTTP request from the public service method and dispatches them to do XXX methods defined in this class. This class is HTTP servlet. Now we are referring here. Void service servlet request servlet response dispatches client request to the protected service method. Here you can see Servlet Container, Servlet, load and instantiate Servlet, web service connected to load and instantiate Servlet, and load and instantiate Servlet is connected to init method. Init method is connected to service, do get request response, do post request response, etc. And request handling is interacts with threads. Threads are threads interacts with web server. Threads HTTP response is passed from threads to HTTP server, and HTTP request is passed from web server to threads, and request handling is connected to destroy method here. Here you can see a state transition diagram for asynchronous operations. With asynchronous processing, sometimes a filter or servlet is unable to complete processing of a request without waiting for a resource or event before generating a response. For example, servlet may need to wait for an unavailable JDBC connection for a response from a remote web service, for a JMS message, or for an application event before processing to generate a response. Waiting within the servlet is an insufficient operation, as it is a blocking operation that consumes a thread and other limited resources. Frequency slow resource such as database may have many threads blocked waiting for access, and can cause thread starvation and poor quality of service for an entire web container. An asynchronous processing of a request is introduced to allow the thread to return the container and perform other tasks. When asynchronous processing begins on request, another thread or callback may either generate the response and call complete, or dispatch the request so that it may run the context of the container using async context dot dispatch. A typical sequence of events for asynchronous processing is: request is received and passed via normal filters for authentication, etc. to servlet. The servlet processes the request parameters and or content to determine the nature of the request. 3. The servlet issues requests for resource or data, for example, send remote web service request or joins a queue waiting for JDBC connection. 4. The servlet returns without generating a response. 5. After some time, the request resource becomes available. The thread handling that event continues to processing either in the same thread or by dispatching a resource dispatching to a resource in the container using async context. Jakarta E features such as web application environment, propagation, security, identity in Jakarta Enterprise Bean calls are available only to threads executing the initial request, or when the request is dispatched to the container via the async context dot dispatch method. Jakarta E features may be available to other threads operating directly on the response object via the async context dot start runnable method. The at web servlet and at web filter annotations have an attribute async supported that is a boolean with the default value of false. When async supported is set to true, the application can start asynchronous processing in a separate thread by calling start async, passing it a reference to the request and the response object, then exit from the container on original thread. This means that the response will traverse in reverse order the same filters or filter chain that were traversed on the same way in. The response isn't committed till complete is called on the async context. The application is responsible for handling concurrent access to the request response object if the async task is executing before the container initialized dispatch that called start async has returned to the container. Dispatching from the servlet that has async support equal true to 1, where the async supported is set to false is allowed. In this case, the response will be committed when the service method of the servlet that does not support async is exited, and it is container's responsibility to complete on the async context so that any interested async listener instances will be notified. The async listener dot onComplete notification should also be used by the filters as a mechanism to clear up resources that they have been holding on to for async task to complete. Dispatching from the asynchronous servlet to an asynchronous servlet would be dispatching from a synchronized servlet to an asynchronous servlet would be illegal. However, the decision of throwing an illegal state exception is deferred to the point when the application call start async. This would allow a servlet to either function as a asynchronous or function as a synchronous or asynchronous servlet. Async task that the application is waiting could write directly to the response on a different thread than the one that was used for initial request. This thread knows nothing about any filters. If a filter wanted to manipulate the response in the new thread, it would have to wrap the response when it is processing the initial request. On the way in, the past wrapped response to the next filter in the chain and eventually to the servlet. So if the response was wrapped possibly multiple times, once per filter, the application processes the request and writes directly to the response. It is writing to the response wrapper. That is, any output added to the response will still be processed by the response wrappers. When an application reads a request in a separate thread and adds output to the response, it's really reads from the request wrapper and writes to the response wrapper. So any input and output or output manipulation intended by the wrapper will continue to occur. Alternatively, the application chooses to do so, it can use the async context to dispatch the request from the new thread to resource in the container. This would enable using content generation technologies like Jakarta server pages within the scope of the container. Here we can consider some methods. You can see the public async context start asyncs. This method provides as a convenience that uses the original request and response object for asynchronous processing. Please note that the users of this method should flush the response if they are wrapped before calling this method, if you wish to ensure any data written to the wrapped response isn't loose. Here you can see public void dispatch provide as a convenience to dispatch the request and response used to initialize the async context as follows. If the async context was initialized via the start async servlet request also servlet response, and the request passed is an instance of HTTP servlet request, then the dispatch is to the URI returned by the HTTP servlet request.get request URI. Otherwise, the dispatch is to the URI of the request when it was last dispatched by the container. And you can see the complete here, public void complete method. If the request dot start async is called, when this method must be called to complete the async processing and commit and close the response. The complete method can be invoked by the container if the request is dispatched to a servlet that does not support async processing, or the target servlet is called by async context dot dispatch does not do the subsequent call to the start async. In this case, it is it is the container's responsibility to call complete method as soon as the servlet's service method is exited. An illegal state exception must be thrown if start async was not called. It is legal to call this method anytime after a call to servlet.start async method or servlet.start async servlet request servlet response method, and before a call to one of the dispatch methods. If this method is called before the container initiated dispatch that called start async has returned to the container, following conditions must hold during the time between invocation of complete and the return of the controller to the container. One, the behavior specified for complete will not take effect until after the container initialized initiated dispatch has returned to the container. 2, any async listener dot on complete async event invocations will also be delayed until after the container initiated dispatch has returned to the container. 3, any calls to request dot is async started must return true until after the container initiated dispatch has returned to the container. Here the void dispatch dispatches the request and response object of this async context to the servlet container. Here the void completes the asynchronous operation that was started on the request that was used to initialize this async context, closing the response that was used to initialize this async context. Here the do filter. The do filter method of the filter is called by the container which the time actually this is with the container each time the request time a request response pair is passed through the chain due to the client request for a resource at the end of the chain. Filter chain passed to this method allows the filter to pass on the request and response to the next entity of the chain. There is no need to override this method. And this void service servlet request servlet response method called by the servlet container to allow the servlet to respond to a request. Here you can see starting is connected to dispatching. Dispatching is connected to dispatched state. Do filter or service method is passed from dispatching to dispatched state. Dispatch state is connected to sync started state or completed state. Start sync is passed from dispatch to sync started state. Sync started state is connected to sync wait state and completing state. Return is passed from sync started state to sync wait. And sync wait is connected to dispatching and completed state. Dispatched method is passed from sync wait to dispatching, and completed is passed from sync wait to completed. Here async started is connected to redispatching and completing. Dispatched method is passed from async started to redispatching state. Redispatching is connected to dispatching. Return is passed from redispatching state to dispatching, and async start is connected to completing. Complete method is passed from async started to completing, and completing is connected to completed. Return is passed from completing to completed, and completed is connected to the end, the complete. As an example, we can consider module jakarta.servlet. As an example 2, we can consider package jakarta.servlet. The jakarta.servlet package contains a number of classes and interfaces that describe and define the contracts between a servlet class and the runtime environment provided for an instance of such a class by confirming Servlet Container. For versions prior to 4.0.2, these classes and interfaces are described by the Java Servlet API specification. For versions 4.0.2 and later, they are described by the Jakarta Servlet specification. This is in module jakarta.servlet. As an example 3, we can consider interface servlet. Define methods that all servlets must implement. This is in package jakarta.servlet and in module jakarta.servlet. As an example 4, we can consider this code segment. This is at web servlet annotation. Example, following is an example of how this annotation would be used. The annotation type web servlet. Annotation is your annotation used to declare a servlet. This is in the module jakarta.servlet and in the package jakarta.servlet.annotation. Here the at web servlet, this annotation is used to define a servlet component in a web application. This annotation is specified on a class contains metadata about the servlet being declared. The URL patterns or the value attributes on the annotation must be present. All other attributes are optional with the default settings. It is recommended to use value when only attributes on this on the annotation is the URL pattern, and to use the URL patterns attributes when the other attributes are also used. It is illegal to have both value and URL patterns attributes used together on the same annotation. The default name of the servlet, if not specified, is the fully qualified class name. The annotated servlet must specify that at least one URL pattern to be deployed. If the same servlet class is declared in the deployment descriptor under different name, the new instance of the servlet must be instantiated. If the same servlet class is added with the different name to the servlet context via the programming API defined in programmatically defined, the attributes values declared via the at web servlet annotation must be ignored, and a new instance of the servlet with the name specified must be created. The classes annotated with at web servlet class must extend jakarta.servlet.http.servlet http servlet class. As an example 5, we can consider this code segment at web servlet annotation. Example using other annotation attribute specified. Following is an example of this annotation would be used with some more of the attribute specified. Here annotation type web servlet. Annotation is used to declare a servlet. This is in the module jakarta.servlet and package jakarta.servlet.annotation. Here the name, the optional element, the name is the name of the servlet is in string type, and this is string array or URL patterns. This is the URL patterns of the servlets. As an example 6, we can consider this, the Jakarta servlet example. In this servlet class, we injected the existing greeting service to handle the message. Here the the class HTTP servlet provides an abstract class to be subclassed to create an HTTP servlet suitable for a website. A subclass of HTTP servlet must override at least one method, usually one of these. Do get if the servlet supports HTTP GET requests. Do post for HTTP post request. Do put for HTTP put request. Do delete for HTTP delete request. Init and destroy to manage resources that are held for the life of the servlet. Get servlet info, which the servlet uses to provide information about itself. There's almost no reason to override the service method. Service handles the standard HTTP requests by dispatching them to the handler methods for each HTTP request by type. The do xxx methods listed here. This is in the module jakarta.servlet and package jakarta.servlet.http. Here write message to the HTTP response. Here Jakarta servlet and pages example. We refactor the previous example and split page view part into a standalone page file. Here the method request dispatcher get request dispatcher string path returns a request dispatcher object that acts as a wrapper for the resource located at the given path. A request dispatcher object can be used to forward a request to the resource or to include the resource in a response. The resource can be dynamic or static. This method is in the interface servlet context, and it's in the package jakarta.servlet and module jakarta.servlet. Here put the message object into the request attribute. In the page view, it can be read from the request scope directive. This make it HTML5 declaration compatible. Here as an example, we can consider life cycle of a servlet. The three methods are central to the life cycle of a servlet. There are init, service, and destroy. They are implemented by every servlet and are invoked at a specific time by the server. During initialization stage of the servlet lifecycle, web container initializes the servlet instance by calling init method, passing an object implementing the java x dot servlet config interface. This configuration object allows the servlet to access name value initialization parameters from the web application. Actually with Jakarta, it's jakarta.servlet.servletconfig interface. This configuration object allows the servlet to access the name value initialization parameters from the web application. After initialization, the servlet interface, the servlet instance can service client request. Each request is serviced in its own separate thread. Web container calls service method of the servlet for every request. The service method determines the kind of request being made and dispatches it to an appropriate method to handle the request. Developer of the servlet must provide an implementation for these methods. If a request is made for a method that is not implemented by the servlet, the method of the parent class is called, typically resulting in an error being returned to the requester. Finally, the web container calls the destroy method that takes the servlet out of service. The destroy method, like init, is called only once in the life cycle of a servlet. The following typical user scenario following is a typical user scenario of these methods. One, assume that user requests to visit a URL. The browser then generates an HTTP request for this URL. This request is then sent to the appropriate server. Two, the HTTP request is received by the web server and forwarded it to the servlet container. The container maps this request to the particular servlet, and the servlet is dynamically retrieved and loaded into the address space of the container. 3. The container invokes init method of the servlet. This method is invoked only when the servlet is first loaded into the memory. It is possible to pass initialization parameters to the servlet so that it may configure itself. 4. The container invokes service method of the servlet. This method is called to process HTTP requests. The servlet may read data that has been provided in the HTTP request. The servlet may also formulate an HTTP response to the client. Five, the servlet remains in the container address space and is available to process any other HTTP request received from the client. The service method is called for each HTTP request. The container may at some point the container may at some point decide to unload the servlet from its memory. The algorithms by which this decision is made are specific to each container. And number 7, the container calls the servlet's destroy method to relinquish any resources such as file handles that are allocated for the servlet. Import data may be saved to a persistent store. And 8, the memory allocated for the servlet and its objects can then be garbage collected. This example servlet prints how many times its service method was called. Note that HTTP servlet is a subclass of generic servlet and implementation of the servlet interface. The service method of HTTP servlet class dispatches requests to the methods doGet, doPost, doPut, doDelete, and so on according to the HTTP request. In this example below, the example here, service is overridden and does not distinguish which HTTP request method it serves. This is accessing a local variable. As an example 10, we can consider a servlet declared via an annotation and packaged with the corresponding web.xml in the descriptor. Optional here the optional element webinit param array init param. The init parameters of the servlet you can see the name and the value here for the parameter. So as an example 11 here you can here, since the name of the servlet declared via the annotation does not match the name of the servlets declared in web.xml, the annotation specifies the new servlet declaration in addition to the other declaration in web.xml. As an example 12 here we can consider this code segment If you define information for a particular servlet by declaring init param tag inside the servlet tag, this information will not be available to other servlets of the application, and we get this using servlet config. This is in file web.xml. Here you can this example we can consider interface servlet config, a servlet configuration object used by the servlet container to pass information to a servlet during initialization. Here writing the message on the web page. As an exception example, we can consider class servlet exception. Defines a general exception a servlet can throw when it encounters difficulty. This is in module jakarta.servlet, package jakarta.servlet. As an error example, we can consider this error. The support class jakarta.servlet.http servlet was not found on the Java build path. This error occurred in environment with Eclipse IDE for enterprise Java and web developers. Now we are focusing on data source. In the JDBC API, databases are accessed by using data source objects. A data source has a set of properties that identify and describe the real-world data source that it represents. These properties include such information as the location of the database server, the name of the database, the network protocol used to communicate with the server, and so on. In Glassfish server, the data source is called a JDBC resource. Here you can see business tier and EIS tier. With the business components, the business code, which is logic that solves and meet the needs of need of a particular business domain, such as banking, retail, or finance, is handled by enterprise beans running in either business tier or the web tier. This figure shows how an enterprise bean receives data from client program. Process it if necessary and send it to the enterprise information system tier for storage. An enterprise bean also receives data from storage, process it if necessary, and send it back to the client program. With the enterprise information system tier, the enterprise information system tier handles EIS software and includes enterprise infrastructure systems such as enterprise resource planning, ERP, mainframe transaction processing, database systems, and other legacy information systems. For example, Jakarta EE application components might need access to enterprise information systems for database connectivity. Here you can see application client and optional Java Bean components interacts with EIS tier, and application client and optional Java Bean components and web browser, web pages, applets and optional Java Bean components are inside client tier, and client tier is connected to client machine. Web browser, web pages, applets and optional Java Bean components are connected to web tier, actually interact with web tier. Java Beans components optional and web pages servlets are in web tier. Java Bean components optional interacts with web pages and servlets. Java Bean component optional interacts with Jakarta persistent entities, session beans, and message driven beans. Jakarta persistence entities, session beans, and message driven beans are inside business tier. Web tier and business tier are connected to Jakarta EE server. Jakarta persistent entities, session beans, and message driven beans are connected to EIS tier. EIS tier. EIS tier, the database and legacy systems are inside EIS tier. EIS tier is connected to database server. Here you can see Jakarta EE APIs in the enterprise bean container. In this color, on blue color, you can see the new in Jakarta EE. This figure shows the availability of Jakarta EE APIs in the enterprise bean container. Here you can see EGB is inside EGB container. EGB is connected to new in Jakarta EE. These are concurrency utilities, batch and JSON-P. These are new in Jakarta EE. And bean validation, Jakarta mail, connectors, Jakarta persistence, JMS management, WS metadata, web services, JACC, JASPIC, JAX RS, JAX WS, JTA, CDI, dependency injection, and these APIs are connected to Java SE. Jakarta Enterprise Bean technology, an Enterprise Bean component or Enterprise Bean is a body of code that has fields and methods to implement modules of business logic. You can think of an Enterprise Bean as a building block that can be used along or with other Enterprise Beans to execute business logic on the Jakarta EE server. Enterprise beans are either session beans or message driven beans. A session bean represent a transient conversation with the client. When a client finishes executing, the session bean and its data are gone. A message-driven bean combines features of a session bean and a message listener, allowing a business component to receive messages asynchronously. Commonly, these are Jakarta messaging messages. The Jakarta EE platform requires Jakarta Enterprise Bean 4.0 and Jakarta Interceptors 2.0. Here you can see Servlet server pages accessing enterprise beans. This is with transaction management. Product providers must transparently support transactions that involve multiple components and transactional resources within a single Jakarta EE product. This requirement must be met regardless of whether Jakarta EE product is implemented as a single process, multiple processes on the same network node, or multiple processes on multiple network nodes. If the following components are included in Jakarta EE product, they are considered transactional resources and must behave as specified here. JDBC connections, Jakarta messaging sessions, resource adapters, resource adapter connections for resource adapter specifying XA transactional level. A Jakarta EE product that includes both the Servlet Container and an enterprise bean container must support a transactional application comprised of combination of web application component accessing multiple enterprise beans within a single transaction. If the Jakarta EE product also includes support for connectors specification, each component may also require one or more connections to access one or more transactional resource managers. For example, in servlets, server pages accessing enterprise beans, the call tree start from the from a servlet or server pages accessing multiple enterprise beans, which in turn may access other enterprise beans. The components access resource managers via connections. The application components provider specifies using a combination of programmatic and declarative transaction demarcation APIs how the platform must manage transaction on behalf of the application. For example, the application may require that all the components in servlets server pages accessing enterprise beans access resources as part of a single transaction. The platform provider must provide the transaction capabilities to support such scenario. The specification does not define how the components and the resources are partitioned or distributed within a single Jakarta EE product. In order to achieve the transactional semantics required by the application, the Jakarta EE product provider is free to execute the application component sharing a transaction in the same Java virtual machine or distribute them across multiple virtual machines in accordance with the requirement of the component specifications. Here you can see client is connected to JSP or servlet. JSP or servlet is connected to a connection. Connections interact with one or more transactional resource managers. JSP or servlets connected to EJBs, enterprise Java Beans. Enterprise Java Beans Java Bean is connected to Java Beans are connected to connections are connected to connections interacts with one or more transactional resource managers. Enterprise Java Beans are connected to other enterprise Java Beans. These enterprise Java Beans are connected to connections. These connections interacts with one or more transactional resource managers. As an example of at resource annotation follows the annotation type resource. The resource annotation marks a resource that is needed by the application. This annotation may be applied to an application component class or to fields, methods. The container will inject an instance of the requested resource into the application components when the components is initialized. If the annotation is applied to the component class, the annotation declares a resource that the application will look up at runtime. This is in package jakarta.annotation. Here the at resource annotation, the at resource annotation is used to declare a reference to a resource such as a data source, Jakarta messaging, JMS destination or environment entry. This annotation is equivalent to declaring a resource ref, message destination ref, or env ref or resource enref element in the deployment descriptor. The at resource annotation is specified on a class, method, or field. The container is responsible for injecting references to resources declared by at resource annotation and mapping it to the proper GNDI resources. In this example code, a servlet, a filter or listener declares a field catalog ds of type javax.sql.data source, for which the reference to the data source is injected by the container prior to the component being made available to the application. The data source GNDI mapping is inferred from the field name catalog ds and type javax SQL data source. Moreover, the catalog ds resource no longer need to be defined in the deployment descriptor. Here get a connection and execute query. And as an example too, we can consider this. For example, you can create a resource definition like this. And this is in the file /web inf/web.xml and this is in Tomcat 10.1. As an example 3, we can consider this. A servlet or enterprise bean can then get the data source injected with code that is similar to this example. And here you can see the optional element public abstract string name, the GNDI name of the resource. For fields annotations, the default is the field name. For method annotation, the default is the Java Beans property name corresponding to the method. For class annotations, there is no default, and this must be specified. And this is from the framework openliberty.io. As an example 4, we can consider this code segment, the annotation type data source definition. Annotation is used to define a container data source to be registered with JNDI. The data source may be configured by setting the annotation elements for commonly used data source properties. Additional standard and vendor specific properties may be specified using the properties elements. Here you can see string name, the required element, JNDI name by which the data source will be registered. Here you can see the required element string class name, the name of a data source class that implement javax.sql data source or javax.sql xa data source or javax.sql.connection pool data source. Here you can see optional element int port number. Port number where a server is listening for requests. Here you can see string server name, database server name. Here you can see string user, username to use for connection authentication. Here you can see the optional element string password to use for connection authentication. Here you can see using a URL. Here you can see the optional element string URL, a JDBC URL. Here you can see an example lookup of the data source from and Jakarta Enterprise Beans. Here you can see the optional element lookup, string lookup, the name of the resource that the reference point to. This is end of my presentation. Thank you very much for watching it.